So the moon is uniquely positioned. It's 400 times smaller than the sun is, but 400 times closer to us than the sun is, which means that from our perspective, the disks of the sun and moon are the same size. And the moon has an orbit that frequently brings it in between the Earth and sun. And if you're at the right spot on the Earth when that happens, then you can see total solar eclipse, where the disk of the moon just perfectly blots out the disk of the sun. I don't know if anybody took the opportunity a few years ago to see the total solar eclipse when it was like Oregon, which is still a trip from here, but closer than elsewhere on the planet. There's another one coming to the U.S. next April in the southeastern part of the country. So if you do have the chance to travel, these are well worth seeing. I mean, it's awe-inspiring. Moment of totality is everybody just, wow. So worth the experience. But my point right now is that this is really an amazing coincidence, if you think about it, that the moon and the sun are going to be exactly the same size. This. Turns out there's over 200 moons throughout our solar system. And of all these moons, how many of them have the proper combination of orbit, distance, and size to produce these events for observers on their surface? One. Only our moon produces these events for the planet it orbits. As an astronomer friend of mine says, kind of tongue-in-cheek, isn't it a coincidence that the only place in the solar system when these events are observable is also the only place where there are observers to observe them? So does all this look like the random processes operating over long periods of time, or does it look designed? It looks designed because indeed the moon was designed to be the lesser light to rule the night. It does that very well. As I quoted this phrase, that might bring to mind another phrase where the sun is described as the greater light to rule the day. So let's talk about the sun. Is the sun designed? Yes, actually there's lots of evidence for design of the sun. First of all, it's very important, it's crucial to life on Earth, again, something we don't often think about. But the sun provides warmth for us. Without the sun, the only source of warmth on Earth would be radioactive decay on the planet, which is very inadequate to support life here. It also ultimately provides all of our food. Because solar energy powers photosynthesis, plants grow, and then we eat the plants and we eat other things that eat plants. So the sun ultimately produces, in a sense, all of the food that we consume. It's also responsible for the oxygen that we breathe, and from plants. So the sun is obviously very important to us. But secular scientists have said that the sun isn't really anything to get excited about, that it's just an average, ordinary star. Carl Sagan said, "Who are we? What are we? We find that we live on an insignificant planet of a humdrum star, lost in a galaxy tucked away in some forgotten corner of a universe in which there are far more galaxies full." Not a very optimistic outlook there, is it? This author said, "Our star, the sun, is rather ordinary. In many respects, the sun is entirely a run-of-the-mill entity." This author said, "Our sun, so important to us, is merely an ordinary garden-variety star." So is this true? Is the sun mediocre? Just average, humdrum, garden variety? No, our sun is very unusual. For example, our sun's brighter than 90% of all the stars in the Milky Way galaxy. It has more mass than 92%. In fact, if our sun were an average star, it would be a red dwarf because about 75% of all stars are red dwarfs. And as you might gather by the name, red dwarfs are red and small. And they're red because they're much cooler than our sun, so they produce much less energy than our sun does. So if our sun was a typical star, it would be a red dwarf because that's what a typical star looks like. But we should be very glad our sun is not a typical star. For one thing, if our Earth orbited a red dwarf, then we would have to orbit it much more closely in order to receive enough energy and warmth for life to be possible here. In fact, we'd have to orbit it so closely that we'd be in a tidal lock. So a tidal lock happens when one object is orbiting a second one, and the orbiting object always has the same side turned toward the object it's orbiting. So our moon, for example, is tidally locked to the Earth. That's why we always see the same side of it, right? Sometimes it's lit up, sometimes it's not. But it's still always the same side of the moon facing the Earth. Well, the same thing would be true of the Earth facing the sun if the sun were a red dwarf and we had to orbit that closely. So this would be very bad for life on our planet, right? Because one side would always roast and the other side would always freeze. Not very conducive to life. If You also don't want to be orbiting a red dwarf star closely in the first place because red dwarfs are very unstable. They're often called flare stars. They frequently erupt blast material out into space, and you don't want to be caught in the path of one of those. So indeed, our sun is not a typical star, and we should be very thankful for that because life here probably wouldn't be possible for very long. But even among high-mass stars, the sun is very unusual because about 80% of high-mass stars are in binary or multiple star systems where two or more stars orbit their common center of mass. And again, we should be very thankful that we live in a single star system, not a multiple star system, because in a multiple star system, sometimes you're receiving energy from just one star, sometimes you're receiving energy from multiple stars, depending if they're blocking each other from your view or not. So again, the amount of energy you receive fluctuates wildly, and life would be very difficult in those circumstances. Our sun is a class G star, which is only about 7.5% of all stars. So again, unusual. But even among class G stars, our sun is unusual because it's very quiet. A while back, a 30-year study of the sun's photosphere was completed, where they found that the energy output of the sun varied by less than 1/10 of 1%. They said the sun is basically constant in temperature. And we take that for granted, right? I mean, the sun goes up in the morning, it goes down in the evening, we go about our business and don't think about it. But stars don't behave this way. Even solar-type stars don't do this. There have been studies of solar-type stars. Now, these are the stars that are most like our sun. And even solar-type stars have superflares about once per century on average. So what is a superflare? Well, you're probably familiar with the fact that our sun's surface is active. All sorts of interesting physics going on the surface of the sun. But there's these flares where the sun emits here, and frequently accompanied by eruptions of material out into space as well. And you can see the size of the Earth relative to some of this activity. So some of these are very large. But a typical flare in our sun doesn't affect us on our planet. I mean, a really big one may affect communications or something briefly, but that's only a technology issue. It doesn't affect life in general. Imagine, though, a typical solar flare multiplied by a factor of 10 million. So a superflare, that's what a superflare is. So a superflare is 10 million times greater than a typical flare on our sun. That's what a solar-type star normally does, and that happens about once per century, which is scarily frequent. As this author noted, sun-like stars normally produce a bright superflare about once a century. Why a superflare has not occurred on the sun in recorded history is unclear. It's not unclear, just read your Bible. The Lord created the sun to support life on earth. So that's what it does very well. And just for perspective about what stars are like, I mean, we perceive them as these friendly, twinkly little things in the sky. No, stars are not typically things you want to be snuggling up next to. This one here is in the process of exploding, as you can see. This one here is exploding in two different directions at once. Stars are not all unstable like this. These are extreme examples, admittedly. But still, my point is, stars are not these friendly little things in the sky. Our sun is. The rest of them are not. As this author said, some of the popular perception of the sun is downright wrong. Writers sometimes tell us that it is just an average star. Not so. The vast majority of stars are smaller, cooler, dimmer, and less massive than the sun. The author said, people say the sun is a typical star, but that's not true. Almost all environments in the universe are terrible for life. Only Garden of Eden places like the Earth where it can exist. So again, random processes or design? The sun is unique. It looks designed for us. What about a larger scale? What if we look on the level of galaxies? Is there evidence for design there? Well, yes, there is actually. Now, some of what I'm about to share is actually from a secular perspective. Some of the things I'm about to talk about don't apply if all of this was created recently. It only applies if you believe in the billions of years. But I think it's interesting that the Lord has created things in such a way that even if you do try to believe in the billions of years and try to deny what the Bible says, you have to grapple with all these sorts of issues. So if you're a secular scientist trying to say, well, where could life have evolved, etc., turns out your options are really limited. For example, you don't want to have life in globular clusters. These are large spherical collections of stars. These are called dead zones because life there basically would not be possible. The stars are metal poor, meaning they don't have the proper composition that scientists would expect to have life there. And you have a lot of orbital perturbations. You're close to a lot of stars at any given point, which means your planet going around the star is going to be pulled hither and yon, so to speak. So your orbit around your star is going to be much less circular than ours is, so the amount of energy you vary, and that's not good for life. Turns out you need to be in a galaxy, but not just any galaxy. You don't want to be in an elliptical galaxy, because those are dead zones too. Again, the stars have the wrong composition, and again, you'd have orbital problems with the planet. Now, it turns out you want to be in a spiral galaxy, which our Milky Way is, but you don't want to be just anywhere in a spiral galaxy. You don't want to be in the center, because there's lots of nasty stuff at the center of galaxies. You'll be next door to supernova explosions, gamma ray bursts, neutron stars, and all sorts of nasty stuff that mean life there isn't going to survive very long. But you also don't want to be out on the edge, because there's other problems there. Again, the composition of stars aren't what people would expect for life to be there. No, you want to be about halfway out from the center to the edge, and it turns out that's exactly where our sun is, Milky Way. And not only are we in the proper distance from the center and the edge, it also turns out we are not within the middle of a spiral arm, which A, is good for life, because in the middle of an arm we'd be receiving more radiation from other stars, but B, because we're not in a spiral arm, it means we can see outside of our galaxy. So we can look inwards and see our galaxy itself, but we can also look up and down and perceive deeper universe outside of our galaxy. So not only is our position in the galaxy designed for life, it's also optimally placed to observe the heavens, Lord's glory, so doing. Lots more we could talk about along these sorts of lines, evidence for design and how unusual Earth and the solar system and the galaxy and all of this is. I'm not going to spend more time on this other than to just summarize some of the things that even from the secular perspective, people have had to grapple with. For example, our solar system appears to be designed to support life because the types and distribution of planets within it is ideally situated for that. Turns out that if you want to have ideal conditions for life, you don't want to have another Jupiter or Saturn in the solar system. You don't want to have any giant planets in eccentric orbits, meaning they would more oval and interfere with our orbit. You also can't have what are called hot Jupiters, where there's a Jupiter-sized planet closer to the sun. Our solar system doesn't have that, but it turns out as we're looking at other solar systems that that's very common. Jupiter is actually very important in its own right because you can't, Jupiter actually protects the Earth in many ways. You have potential impactors coming in from space, comets, asteroids, whatever. Jupiter is so large that it has such gravity, it's pulling those things toward itself. We've actually watched this happen a number of times, and thus shields the Earth from being hit by objects from space. So you need a Jupiter in your solar system to have it be optimal for life. But you can't be too close to it, and you also can't be too far. It has to be just right. Other factors for the Earth needs to be the right distance from its star. In order to have liquid water on the surface, you need to be far enough from the star to avoid having a tidal lock like we talked about, but you have to be close enough to be able to support complex life. You need the right mass of the star that you're orbiting, long enough lifetime, and so on. And I'm not going to talk about each of these, just for the sake of time. There's a long list of them, which is kind of my point, that even from a secular perspective, if you don't want to accept that Earth and the solar system and the galaxy are the product of creation, that you have to grapple with all these amazing coincidences and all these parameters that had to line up all just perfectly on their own in order for life to be possible and to flourish here as it is doing. So again, I think it's interesting that the Lord made things in such a way that even if you don't want to accept Him as creator, have to grapple with all of these sorts of issues. And this applies not to the Earth alone. Let's look at a larger scale now, the largest scale of all, and talk about the entire cosmos. In fact, we'll talk about not only the cosmos on the largest scale, but even things on the smallest scale. There's fine-tuning throughout. From the universe all the way down to individual atoms, there's evidence of design. For example, Sir Fred Hoyle, who was certainly no friend of creationists, was investigating the properties of the carbon atom and found that it was so well designed and so finely tuned for its role in life that he was really surprised by it all. He said, Some super calculating intellect must have designed the properties of the carbon atom. Otherwise, the chance of my finding such an atom through the blind forces of nature would be utterly minuscule. The common sense interpretation of the facts suggests that a super intellect has monkeyed with physics, as well as with chemistry and biology, and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question. This author said something similar, and who this author is may surprise you. He said a change of as little as 0.5% in the strength of the strong nuclear force, or 4% in the electric force, would destroy either nearly all carbon or all oxygen in every star, hence the possibility of life as we know it. Change those rules of our universe just a bit, and the conditions for our existence here. Most of the fundamental constants appearing in our theories appear fine-tuned. They were altered by only modest amounts. The universe would be qualitatively different and in many cases unsuitable for the development of life. Now, this person was an evolutionist, so he believes life evolved, but he's showing how difficult it would be and how finely tuned even the laws of physics have to be. For example, if protons were 0.2% heavier, they would decay into neutrons, destabilizing atoms. Our universe and its laws appear to have a design that both is tailor-made to support us, and if we are to exist, leaves little room for alteration. That is not easily explained and raises the natural question of why it is that way. So who said this? Stephen Hawking, the militant atheist, if you know that about him. So even at the smallest levels, the laws of physics themselves, the forces that hold atoms together, that's all finely tuned and evidence for design. But even on the broader scale, the broadest scale, the universe itself, we see extreme fine-tuning as well. For example, a few years back, some scientists were working on the Big Bang model. I don't accept, by the way, but they do, so let's take their perspective. And they realized that the Big Bang model had to be extremely finely tuned in the very beginning of it. So the Big Bang model says that there was this cosmic explosion, if you will, not strictly speaking an explosion, but whatever. So all this energy formed, and you had all this stuff expanding out of this event. Now, it turns out there's a tension here because expansion is trying to force the universe apart, according to this idea. But at the same time, you have all of this material that's pulling on each other through gravity, trying to pull it all back together again. So you have expansion pushing out, gravity pulling in, and it turns out the Big Bang model is very finely tuned between those two forces, if you will, those two effects. If you had extra matter, extra stuff coming out of the Big Bang, then gravity would dominate, and they realized everything would pull itself all together, and the universe would be very different. Because if gravity took over early in the Big Bang, all the matter would collapse into black holes, stars wouldn't form, galaxies wouldn't form, we couldn't be here. On the other hand, if there was less stuff coming out of the Big Bang, then expansion would take over, everything would expand too quickly. Again, galaxies couldn't form, stars couldn't form, planets couldn't form, we wouldn't be here to see it all. So what is the margin of error in the Big Bang model between having too much matter and too little matter compared to what we have in the universe today? They realize the answer is 1 out of the 10 to the 60th power. So write a 1 with 60 zeros after it, 1 out of that number is your margin of error for the Big Bang model. So if that's just a big number, what does that mean? Well, there's about 10 to the 80th atoms in the universe, and if the Big Bang that allegedly made this universe was finely tuned to 10 to the 60th, then the precision for the Big Bang, this margin of error, was 10 to the 20th atoms. That's about the amount of stuff in a single grain of sand. So imagine the entire universe, not just this planet, but all the galaxies throughout the entire cosmos, all of this stuff. The Big Bang that supposedly made all of this had to be finely tuned to a single grain of sand. If made an extra grain of sand's worth of stuff anywhere in the cosmos, everything would have collapsed into black holes. And we wouldn't be here to be talking about this. If it had made 1 grain of sand less than what the universe currently contains, runaway expansion. Galaxies, planets, stars wouldn't form. We wouldn't be here to be talking about it. Does this sound like a random event to you? No. Then the problem got worse. The fine-tuning in the Big Bang model is now up to 10 to the 123rd power. That's 1 out of this number is the fine-tuning of this random event. As this author said, our universe appears surprisingly fine-tuned for life, in the sense that if you tweaked many of our constants of nature by just a tiny amount, life as we know it would be impossible. Some of the fine-tuning appears extreme enough to be quite embarrassing. For example, we need to tune the dark energy to about 123 decimal places to make habitable galaxies. So again, it's just a big number. What does that mean? Well, if there's 10 to the 80th atoms in the universe, fine-tune everything to 10 to the 123rd, now you're down to fine-tuning that's less than a grain of sand. You're down to fine-tuning that's less than one atom within a grain of sand. You're down to 10 to the minus 43rd of an atom. That's this fraction of the mass energy of a single atom is how finely tuned this random event had to be for us to be here talking about it all. And again, I'm not saying the Big Bang is even possible, but if you believe that it was and that it did happen, this is what you have to deal with. As this very secular physicist said, this is a cataclysm for physicists. And the only way that we know how to make sense of it is through the reviled and despised anthropic principle, which is the idea that the laws of physics must somehow support life. And you can tell what he thinks about that idea. He doesn't like it because that implies that there's a designer behind it all. So what do secular scientists do with all of this? Well, the obvious explanation is that the universe looks designed because it is designed. But if you're a secular scientist, you don't want to accept that. Some will say that there's survivor bias going on here. That they say, well, of course the universe has to support life, because if it didn't support life, we wouldn't be here to be looking at it anyway. Now, that's not an explanation, right? That's avoiding an explanation for how it did all this. Most scientists are instead appealing to something called the multiverse, and this is indeed more and more the preferred solution to this issue of apparent design in the cosmos. So what is the multiverse? Well, multiverse is a contraction of two words, multiple universes. So the idea is that our universe is not the only universe that exists. There's actually an infinite number of universes out there. And in an infinite number of universes, every possible combination of characteristics will be out there somewhere. So yes, most of them will be average, but there will be a few where everything just happened to line up correctly for life to be possible. We just happen to live in one of those. I want to mention, first of all, you may be confused by the idea that there's more than one universe. A universe means everything, so how can there be more than one everything? Well, they're redefining the word. Universe now means everything you could possibly perceive, even with the best possible technology and so on. So even with the theoretically best telescopes we could ever build, there's limits to our perception. Everything outside of our perception would therefore be in a different universe. And so infinite number of universes out there. Some of them will just happen to have this crazy combination of characteristics. We just happen to live in one of those. And indeed, the Big Bang model has now incorporated this into the very beginning of it. I won't go into details. But cosmic inflation, which is at the very beginning of the Big Bang model, now will produce, according to the people who believe this model, an infinite number of universes just bubbling off in reality constantly. This process has been going on for eternity. It will continue on for eternally long in the future. There's already an infinite number of universes, and more are being made all the time. Now think about this. Any given universe can only contain a certain amount of stuff. And let's think like secular scientists here for a moment. If you're a secular scientist, then you think we're all just particles moving around. Reality is just matter in motion, right? Well, if you have a finite number of particles, there's only a finite number of ways to arrange a finite number of particles. I mean, it'll be a large number of possible arrangements, but still a finite number. If there's a finite number of arrangements, but there's an infinite number of universes, then every possible arrangement of particles will be out there an infinite number of times. This has some implications, as this article said. Is there another copy of you reading this article? A person living on a planet called Earth, with misty mountains, fertile fields, and sprawling cities in a solar system just like this one. The life of this person has been identical to yours in every respect. You probably find this idea strange and implausible, yet it looks like we'll just have to live with it, since the simplest and most popular cosmological model today predicts that this person actually exists in a faraway galaxy. If space is infinite and the distribution of matter is sufficiently uniform, then even the most unlikely events must take place somewhere. I have this phrase highlighted because we're going to come back to this. In particular, there are infinitely many other inhabited planets, including not just one, but infinitely many, with people with the same appearance and memory, same appearance, name, and memories as you. Indeed, there are infinitely many other regions the size of our observable universe where every possible cosmic history played out. So if the multiverse is true, there's an infinite number of universes where we are having this same presentation right now. You are the same person, the same name, the same memories, etc. There's an infinite number where everything is the same as this universe, but you had something different for breakfast this morning. There's an infinite number where the United States and Canada are the same nation because both rebelled against King George III together. There's an infinite number where we're still part of the British Empire together because no rebellion ever happened. Every possibility you can imagine is out there an infinite number of times. Because the most unlikely events must take place somewhere. Now think about the implications of this. If you're only one of an infinite number of copies of yourself, how valuable are you? Are you a unique individual made in God's image? No. I mean, you could go away tomorrow and the larger reality be largely the same because there's still an infinite number of you out there. What does this do to morality? Does it matter how you behave in this universe? When there's an infinite number of you out there that are mass murderers, you can't possibly atone for everything they did. What difference does your actions make now? See the implications of all this stuff. But despite the implications, this is an increasingly popular idea. I mean, some respectable scientists are writing like this, or writing about it, I should say. Even the popular culture is talking about it. Marvel movies have multiverse in it now. This is an increasingly popular topic of conversation among the younger generation. Again, most of us in this room are older, we're not aware of this, but this is getting a lot of traction even among the kids. And that's because the scientists are saying this is true. As this article said, our most successful theories lead to the inescapable conclusion that our universe is just a speck in a vast sea of universes. The multiverse is not some kind of optional thing, like can you supersize or not, says this theoretical physicist. Our own cosmological history tells us that it's there and we need to deal with it. So even though this seems like a really strange idea, you just have to deal with it because this is science, baby. But is it? What's the one thing we know for sure about all these other alleged universes? They are unobservable by definition. We can't observe them even with the best possible technology ever. They're outside of our ability to observe. They're outside of the natural world we can perceive. What word did we use to describe something outside of the natural world? Supernatural. This is a supernatural explanation, isn't it? But we were told at the beginning of this whole process that we're not allowed to use supernatural explanations like creation. So we see some hypocrisy going on here, don't we? And even some secular thinkers are unhappy with this. This one said, these multiverse theories all share the same fundamental defect. They can be neither confirmed nor falsified. Hence, they don't deserve to be called scientific. Multiverse theories aren't theories. They're science fictions, theologies, works of the imagination unconstrained by evidence. This author said, my own moral concerns about the multiverse have more to do with worry that pseudoscience is being heavily promoted to the public. If a wrong idea is promoted for enough years, it gets into the textbooks. Never seen that happen, have we? And becomes part of the conventional wisdom about how the world works. This process is now well underway with multiverse pseudoscience. But this whole idea is worse than just bad science. It's worse than just pseudoscience. It actually has absurd implications because you can use multiverse to prove about anything. As an example, I think this one's kind of fun. If you're ever talking to an atheist who's really committed and informed atheist, you might ask him, are you familiar with Richard Dawkins? And of course he'll say yes. Richard Dawkins has said there almost certainly is no God. Mr. Atheist, do you agree with that statement? Yes. Okay, so let me rephrase the statement and see if you still agree with that. Would you agree that, would you say that it's most unlikely that the God of the Bible exists? Say yes. So, well, that's interesting, Mr. Atheist, because a moment ago you told me there's a multiverse, and in the multiverse, even the most unlikely events must take place somewhere. Therefore, God must exist, right? Now, you're using a false worldview against him in this sense. You can see how multiverse proves about anything you want to, because anything you can imagine is out there an infinite number of times. And indeed, this whole idea has absurd consequences. The Bible says you shall know them by their fruits. So we can apply the same thinking to the Big Bang, which again includes multiverse production at the very beginning of it. We can ask the question, does this whole idea have good fruit or bad fruit? If this is a good scientific model, it would have good fruit, right? If it's a bad model, it would have bad fruit or even absurd consequences. Well, let's look at some of the implications of this whole idea and ask, is this actually science or is it just science fiction? For example, this author wrote that there are infinitely many other regions the size of our observable universe where every possible cosmic history is played out, because even the most unlikely events must take place somewhere, right? Well, that means, among other things, this means that Captain Kirk and Mr. Spock are real people out there an infinite number of times exploring the galaxy. That's what this means, right? Every possible cosmic history is played out. So every science fiction show you've ever seen is real. Even the ones that are so cheesy they're painful to watch are actually out there an infinite number of times. Because remember, even the most unlikely events must take place somewhere. This author wasn't talking about the multiverse specifically, but the same logic applies. He was talking about exploring other planets and running into dinosaurs that had continued evolving on those planets, unlike on Earth where they got wiped out by a freak asteroid collision. And he was worried about this. He said such life forms on these other planets could well be advanced versions of dinosaurs. If mammals didn't have the good fortune to have the dinosaurs wiped out by an asteroid collision on Earth, we'd be better off not meeting them. Yes, you'd be better off not meeting them because there's nothing worse than running into a dinosaur that has better weapons than you do. But if the multiverse is real, this is real, right? If the multiverse is real, there's an infinite number of planets where humans are fighting advanced dinosaurs right this moment. But is it science? Now, I'm having fun with this, obviously. But if the multiverse is real, that's a documentary, right? And who did all this anyway? This author said, it is proposed that our universe was created by life of superior intelligence existing in another physical universe. Intelligent beings might possess not only the knowledge to design, but also the technology to build universes. If the multiverse is real, then there's been an infinite number of universes existing forever. Eventually, you're going to get aliens out there somewhere, according to their way of thinking, that can get technology so good they can create other universes. Maybe that's our universe. This explains why the constants of physics have their observed, finely tuned values. It might even help us to understand why our universe is comprehensible to the human mind. So that's why the universe looks designed. Not because God did it, but because aliens did it. But again, is this science or just science fiction? What about aliens running simulations? This author said, and he's perfectly serious about this, it is a perfectly acceptable supposition that the world as we know it is a vast computer program run on machines built by an intelligence we know nothing about, a universe that could be like any of the ones we speculate about, or one that's totally strange and alien. If you accept the multiverse idea, it is almost inevitable that there are computer-based universes out there. Somewhere among the universes, there would, in all probability, be universes where civilizations had developed far enough to produce a matrix-style universe. Chances are we do live in a computer simulation of a universe. Why does he make that last statement? If you think about the implications of all this, we've had computers in our society for a number of decades now. How many computer simulations has our civilization run during that time? Who knows? It's a very large number, right? Once a civilization develops computers, you eventually reach a very large number of simulations having been run by that society. Let's call it 100 billion, just for having a number to talk about. So you wind up with 100 billion simulations per real civilization. Now, if aliens develop far enough to be able to simulate entire universes, then you're eventually going to wind up with 100 billion simulated universes per one real universe that created the simulations. Still with me? Now, tomorrow morning, you wake up in what you think is a universe. What are the odds that you're in a real universe? 1 out of 100 billion, which is basically 0. So the math here, according to this way of thinking, says there's basically a 0% chance that you live in a real universe and a 100% chance you live in one of the simulations. So you may think that you're living on a real planet and a real cosmos, all the rest of it, but that's all an illusion because in reality you're living inside of a video game that's being played by some alien somewhere. Now you may think this is silly, but an increasing number of scientists are in all seriousness saying that this is true. I showed you this screenshot earlier from Scientific American. There's other articles as well. I mean, just search for alien simulation on the web and you'll find all sorts of articles where this is being talked about. Even some respected scientists, Neil deGrasse Tyson, you probably know his name, very prominent scientist, says it's very likely that the universe is a simulation. This senior NASA scientist is going around giving lectures on it. 2016, the Isaac Asimov Memorial Debate was entirely on this question, where all the panelists agreed, yes, there's lots of evidence. We apparently do live in a simulation. Some scientists are even trying to study and write research papers to narrow this idea down. So my point is, this isn't some crackpot idea. Respectable scientists are talking about it, and again, influencing the culture, even the youth. But let's think about this a little further. If aliens can develop good enough computers that they can simulate entire universes, they can also simulate universes that contain aliens that are simulating entire universes. So maybe, as this author says, in all seriousness, there could be multiple levels of simulation. The computer our universe runs on could be itself a simulation on another computer. So not merely are we living in a computer simulation or video game being played by some aliens, they themselves are living in a video game being played by other aliens. And why stop there? Maybe those aliens are part of a video game being played by other aliens who are themselves part of a video game being played by aliens who are themselves, well, you get the idea. Is this science? No, we've left science far behind at this point. This isn't even science fiction anymore. This is just absurdity. So why is this happening? Why are intelligent men and women promoting this idea? Here's why. As this scientist said, if there's only one universe, you might have to have a fine-tuner. If you don't want God, you better have a multiverse. What's the motivation here? Scientific data? Is the data driving the scientists toward this conclusion? No. The Bible says the fool has said in his heart that there is no God. Now, don't get me wrong, I'm not calling these people stupid. They're very intelligent men and women. Yet they are promoting something that is foolish. Why is that? Because the Bible says the fear of the Lord is the beginning of wisdom. If you deny the truth, then whatever it is you wind up believing has to be a lie, right? When you deny the foundation of wisdom, the Bible, then whatever it is you wind up believing is going to be foolishness. And that's where secular science is today. In fact, as we said, secular scientists reject God, but many are now accepting the idea of alien programmers. Now, interesting implication here. If this idea is true, what do we know about these alleged aliens? Well, a programmer has full control over the program that they write. They can change anything in it at any time. So from our perspective, if we're trapped within a program, these programmers would be omnipotent. A programmer can also monitor what their program is doing and know everything about it at all times. So from our perspective, the alien programmer is omniscient. And furthermore, the programmer can step in at any point at any time throughout the entire simulation they've made. So from our perspective, the alien programmers are omnipresent. What do we call a being that's omnipotent, omniscient, and omnipresent? God. So you have atheists saying they could never believe in God because that idea is scientific. They're perfectly comfortable accepting the idea of a God, as long as that God is not holy, as long as that God doesn't hold them accountable. Then they're perfectly comfortable with that God. You see, this is not a battle of religion versus science. There's religious motivations on the other side of this debate, isn't there? Because they don't want to admit that our cosmos is indeed finely tuned. First of all, they don't want to admit it's even a real cosmos to begin with. But our universe is finely tuned and designed, not the outcome of random processes, designed by a designer, and we know who that designer is. As the Bible says, the heavens declare the glory of God, and the firmament shows his handiwork. The universe does not proclaim the glory of the Big Bang model. It certainly doesn't proclaim the glory of alien programmers. It declares the glory of. So that's the conclusion of my presentation here tonight. I have a website called creationastronomy.com. If you like this sort of event on Astronomy, Cosmology, and Science. I have the newsletter available to you there.